All right, today we are going to be moving into a different branch of finding volume of rectangular prisms. In fact, they're not just rectangular prisms, they can be called composite figures or even irregular shapes. What's interesting about them is that there is no one specific formula that works for them because there are many different types of ways that they can look. For example, previously we were doing rectangular prisms that had a precise length, a precise width, and a height that we could count or have the numbers to. When we're talking about irregular shapes or composite figures, we're actually talking about and looking at that they are composed of multiple different shapes, and in this case, multiple rectangular prisms together. So what we would need to do is use our knowledge about volume of rectangular prisms, and if we make more than one prism or visualize it as more than one prism, find the volume of both, then we have the entire figure. So we're going to take a look at that here. You can right now get a piece of paper. You can try these problems along with me. You can print the ones that I have posted and actually fill them in along with us as well. Big recommendation here for those geometry eyes, this will help you if you don't have those quite yet, is some sort of coloring system. So a highlight, 3 colors is what you would want to use. And not pencil, not gray, because that'll just blend in with the lines. So I'm going to be using 3 different colors to help represent our length, widths, and heights. Okay? Okay, so let's explore first before we jump into our notes with this rectangular prism, and it's very similar to the ones on our notes page. So with this rectangular prism you see here, I have not just a rectangular prism that has a one set length, width, and height. So if we even try to find the length, width, and height, that would be challenging. So can one of my students raise their hand and tell me what they think the length would be of this figure as it is right now? So student 4, what do you think the length is? Student 4, what do you think the length is?
Well, which side is the length? Because it's like held, I don't know if it's supposed to be like held the side, or is that standing straight up or flat?
So that's what's tricky when you're looking at something that's on paper or on screen. You can't really see those 3 dimensions. Shades and stuff help you. But so if I'm holding it, remember length is going like you're laying down. So can you tell me what the length is?
4.
So it does kind of look like 4, right? But what's interesting is we have this gap here, right? Like this gap is making it so we can't say it's truly 4 because it's not 4 right here. It's 4 in these 2 spots, but only 2. Okay, so we can't really say what the length is. Can any of my students say what they think the width is? So remember, width is going, it looks like it's going backwards. What would that be? Do you think, just looking at it the way it is? So my student 3, what do you think?
Is it 3?
It does look like 3. So again, we come across that situation where it's 3 right here, but it's only 2 right here. This gap is causing a problem for us to be able to truly identify which one is the width even. Okay, so student 2, can you tell me which one is the height then?
Height would be 1.
It does look like 1, and really, if no matter which way I look at this and turn it, it is only going up 1, but think about this space again. There's nothing there. It's not going up at all. So really, because this irregular shape, this composite figure, we can't call it just a rectangular prism because it doesn't have a set length, width, and height. It has this gap. So in order to do this, we can break it into other shapes that we can find the volume of, like a rectangular prism, and we can find the volume of those separate prisms and put them together to find the entire volume. So, like I said, on our notes, I have a very, very similar shape. Can you tell where we might cut this one? So student 2, how might you cut this rectangular prism? Do you think or this composite figure into rectangular prisms?
To cut it into, or cut it corner to corner.
Okay, so if I did that, looking here on the screen, you can see corner to corner would do what for me? I would have broken it into 2 shapes, good, but is this going to be have a set length, width, and height, student 2?
No.
No, because what kind of shape is that up on the top?
A trapezoid?
Yeah, and the trapezoid, we can't find the volume. That would actually be if the trapezoid prism instead of a rectangular prism. So we don't have the formula for that. That's out of our league right now. So in order to actually find the length, width, and height of these separate prisms, we have to make a prism. So can any of my students tell me maybe a different cut that would work to make 2 separate prisms? So what do you think, student 3?
Maybe if you went like up and down, like on that corner, if you went straight up.
So tell me, what lines are you kind of looking to start at? Because we have some of them numbered here. Where are you wanting me to start?
At the 4 feet.
Okay, so kind of up here. And where do you want me to draw this, like, cut to?
The 12 feet.
Okay, so when I go to the 12 feet, what you'll notice, and I'm just gonna kind of do a very light dot, that we have a parallel line to all of our widths. It would have to be a cut that is perpendicular, makes a perpendicular line into another line. So you can see that it's parallel to other lines in my irregular shape here. And what it also does is it cuts another line perfectly 90 degrees. So that would work. Then what we like to do is really identify these as 2 different prisms. We can call one Prism A and Prism B. So I'm going to call this one A, this one B. It technically wouldn't matter because we're eventually going to put them together anyways. Now here's the difficult part, is figuring out the measurements to some of the missing pieces or where we cut. All right, so looking at this problem and now having it already cut, I also want to consider, like, the story problem's talking about a raised garden bed in a backyard. Perfect time of year, springtime, making those gardens all squared away for the summer. Is that if we wanted to find the volume, it would be because we were filling it with soil, and when we purchased it, we'd need to know how many cubic amounts of soil we were going to put in there. So you can see our cut, and to kind of simulate that, now we have our 2 prisms. So now we're going to analyze what are our length, width, and height of these 2 prisms. So when I look at Prism A right here, I am needing the length. Now remember, length goes side to side. Can one of my students tell me what they think the length is going to be of the rectangular prism A? So my student 2, what do you think?
I think it's going to be 6 because 6 is half of 12 and you're cutting it right in the middle, so.
Yeah, I see this cut right in the middle, and you're right, half of 12 is 6. But we can't for sure tell if this is 6 or if this is 6. There is a way we can look at the rest of our shapes and our rectangular prisms here, our 2 different ones, that there's a number there that might help us prove that it is half. Can you find a number that might help you do that? What do you think, student 2?
There's a number somewhere?
Yeah, there's another number that's going to prove that 6 is for sure the length of this prism. Because, you know, Will, I think it's 12.
12?
I think it's 12.
Because if you would have added something there inside, it would also be the full 12.
Okay, so you're saying that if this is the length, I see where you're getting that 6 from, right?
Mm-hmm.
And this is a length, it is actually half. 6 is half. So you can prove that it stops and starts here. Now, the other thing to always consider, and a good way to start before you start even trying to identify your length, width, and height like we did, is to identify the numbers that you cannot use because you cut it. If you cut it, you can't use it. Now, don't go crazy scribbling it out, because you, like our student just did, he had to use that in some cases to prove that this is 6 if it wasn't already here. So we need to see that sometimes to calculate it too. Okay, so that's the length of prism A. Let's look at the width. Now remember, width is kind of going back. It's showing that depth. Can one of my students tell me what they think the width is for prism A? This is a tricky one. So what do you think, student 4? What do you think the width is?
And I think that it is like the width of the side is 4.
I definitely see this 4 here, right? That's the one you're talking about.
Mm-hmm.
Yeah?
Yeah.
So what's interesting about that 4, it's not the entire width.
Oh, wait, then 8, because it looks the same size as that line over at the other line looks like it's 4, so I would say 8.
So I love how you said that, because you're like, it kind of looks like it. With these numbers, we don't have to guess. We're not eyeballing it. There's no estimating. We can find what the width truly is. So if I said that this 4 is not the complete thing, which one is?
The 2.
The 2 is actually which measurement? It's not the width.
Oh, sorry, not the 2. It's kind of hard to see.
Yeah, 2 is actually for the height. It's a height line.
12.
12 we can't use.
Well, aren't those 2 the same size?
Well, no, because width is going back, right? Do they kind of look the same? Is that what you're thinking?
Yeah.
Yeah, they kind of look the same. Again, if it doesn't have a number, we can't assume what it is. We can't guess. So actually what we should probably look at is all of our width lines. See if it gives us any information. So we need this full amount. We need to know that measurement there. So we know this one's 4. Do we have any other width lines? Can any of my other students tell me that if there's any other width lines? Do you see one, student 2?
6.
Oh, okay. So 6 is a width line. Now let's go back to you, student 4. Now that you know that this one's 6 and this one's 4, can you figure out the full thing for prism A? What do you think, student 4?
I said 10.
So how'd you get that 10?
Because 6 plus 4.
Yeah, so if we put those together, we can find out our width is 10. And so 4 plus 6, we got it. Awesome, good job. So what about now the height? The height. Can anyone look at the height, find the height for prism A? Any ideas? What do you think, student 2?
2.
Let's see
Would
here.
the height be 2?
Yes, definitely the height would be 2. And there's no extra calculating we needed to do for that one. And we didn't really have to with length.
That's the only number for height.
Yep, that is the only one. So we can find the volume of prism A. What is the volume of prism A now that we have all 3 measurements that we need? So we have the length, we have the width, and we have the height. Can anyone tell me what it's going to be? What do you think, student 4?
Sorry, I didn't hear you. What did you say?
What do you think the volume is total?
The volume? I think the volume, like as in the just for number A.
Prism A, yep.
I can't see it.
Well, we had a length of 6, a width of 10, and a height of 2.
I think that is.
You calculate it. I'm going to have you check student 2's work. What do you have, student 2?
Would it be 120?
How'd you get that?
Well, because 6 times 10 is 60,
Mm-hmm.
and then 60 times 2 is 120.
Good. So you just followed finding the volume, the formula, and you got 100, what?
20.
20. And quick remembering how we label volume. Any ideas, student 2? Look at the image to know the first part.
Isn't it cubic units?
It is. And do we know what kind of units we're using here? Like centimeters, inches?
Oh, in feet.
Yes. So we can say feet in it, cubic feet. Good. So student 4, what were you able to get that 120? Can you confirm with us that that is what you got as well?
Yeah, I got 120.
Awesome. Okay. So now that we have one prism, we just need prism B now. So can my students help me figure out what would the length be for prism A? Or I'm sorry, for prism B. Anyone help me with that? Go ahead, student 2. What do you think?
I think it's 6.
So the length, you think it's 6. What made you come to that conclusion?
Because the 12 that used to be there,
Okay.
it was cut into half by the other 6. So
Good.
the other half of the 6 would go for the B.
Good. Now I'm going to challenge your thinking here. Is this right here a length line where I'm pointing?
Yes.
Is this right here a length line?
Yes.
That one's not though, is it?
No.
It is.
Wait,
Yeah, all the lines that are parallel to each other are length lines. And so you can kind of see that in what you used for this one. So whether you're looking at this and you're like, oh, that has to be 6 because of the whole thing's 12, then these two pieces go together should be 12. This has to be 6. Or if you were looking at it back here, either way, those are your length lines because it still follows that across pattern. So good. Okay, so our length, it's the same. Just just so happens to be the same doesn't mean it's always going to be the same. All right, so now we need the width. What would be the width? And we kind of have some obvious aspects here already marked for us. What would be the width line, do you think? What do you think? Go ahead, student 3.
6.
Yeah, where'd you get the 6 from?
It was a width line.
Yeah.
I got it because
Sometimes the color coding
I split 12 in half.
So that 12 is a length line. So if we're finding width now, and I have that blue kind of highlighting some of our width lines, where would maybe that 6 width coming from? So you can see Prism B in isolation, right?
Oh, it's already labeled.
Yeah, we already had thought about it because when we were getting the width of Prism A, we had to use the 4 and 6. So in this case, we are just using the 6 because we have this missing chunk right here that we wouldn't do the whole entire 10, okay? So good. All right, let's now look at the height. Can one of my students tell me what they think the height is? All right, so the height would be of Prism B. What do you think, student 3?
I think it would be 6 again.
The height? Now remember, height goes up and down. So what lines and what color coding do we have for height?
I can't really see it.
So our height would be going up and down. We kind of have to look at Prism A. Do you see if anything over by Prism A to find the height?
2 feet.
Yes. So even if I look at my built one here, they're both this same height, right? They're not going up further. They're not stacked at all. So our height line, this is also height line. Kind of like we talked about with one of our other students, is that we can look at the parallel lines to even find ones that might not have a measurement next to it, or look at our other side. So our height of this one is 2. So now what we need to do is find the volume of this prism. So you guys want to go ahead and do that? What do you have for the total volume? Any ideas? Go ahead, student 2.
I think it would be 72.
How'd you get that?
Because 6 times 6 is 36.
Okay.
And 36 times 2 is 72.
Is what?
72.
What do you think, my student 3? Is that correct? That the 6 times 6 times 2, is that 72? Is that our total volume?
I'm still checking.
All right, good. And while she's checking, my other student, will you tell me what the label would be for this one? You did my first one. So student 2, what do you think the label is?
It would be feet or square. Wait, no, feet.
Squared. It is feet. Now squared goes for what kind of shapes?
Area.
Area. Good. 2-dimensional shapes. So if that's 2-dimensional, what's this one?
I can't think of it.
Well, how many dimensions do we need? Or do we have for volume?
How many dimensions? 3?
Yeah. Yeah. So if it's 3 dimensions, it's cubed. It's to the
unit.
3rd power. Yeah. Good. So you say cubic feet.
Yeah, cubic unit.
Or, yep, you got it. All right, so student 3, can you confirm that 72 is our answer?
Yes.
All right, so this is not our final answer. As we said, we need to have both of the volumes added together. So why don't you guys go ahead and calculate that? We had volume of Prism A was 120, and then volume of Prism 2 was 72. What is our total volume for this prism?
192 feet cubed.
I agree, 192 cubic feet or cubed feet. Very good. So now another way to look at this one is, what if we didn't do this cut? Is there another way to make 2 prisms than the one we just did? So there is. So we're going to look and see what we can do to make 2 different prisms, making a different cut. All right, so can you help me figure out how we're going to cut this? What would be a different way? So we're not going to cut, it kind of looks like along the width line is what we just did, right? We broke it in 2 like that. So is there another line? Now remember, we said it creates a perpendicular. When we did that, it made a perpendicular line. Or you could also think it is has to be parallel to one of the lines that already exist. So what do you guys think? Go ahead, student 2.
Horizontal.
So horizontal goes this way being vertical, right? So from where? I'm like kind of cutting what?
From the, like in the middle of like the full.
So like right here?
Right there.
Okay.
And make it to the far left side.
Okay. So now I can see I have 2 prisms, and we're going to label it A and B. Doesn't matter which one. And so I really want you to see here that where our 2 prisms kind of start and stop. Since it's 3-dimensional and it's kind of hard to see with all of these faces that show up on paper, there you can see one of our prisms kind of stand out compared to B. Okay, so now let's look at the length of A. So we have length. Any of those lines, do we have that measurement? What do you guys think? Go ahead, student 2.
Would it be 12?
Why? I see it.
Because it's technically just putting the 12 on the other side of it.
Yeah,
and
so
the other one, you would be adding the 6s together.
Right, so it's not cut at all, so we can use it, and it is the full length of that prism. And so don't get caught up in thinking that length is always down here. We can't see that part, but this line is parallel to it, so we can see that that is in fact 12. So student 3, what do you think about width? Any ideas?
I think it's 6 feet.
So are you right here?
Yeah.
Yeah, that width is going back. It's not cut. It's showing that full width of Prism A. So we have 6. All right, student 2, what about our height line?
It would be 2 again.
Yeah, and where did you have to look to get that?
For all the way over at Prism B.
Yeah, it's all the way over here, but on this prism, it happens to be the same, but we use that one. Good. So sometimes, like we did before, we had to kind of look around for it. Good, so our height is 2. And sometimes I even like to label it over the side if I ended up having to think about it in a different location. All right, so what's the volume of this prism? Let's calculate this together. So as you guys did before, 12 times 6 times 2. Sometimes I mix and match which one I multiply first. Go with the easiest thing to do mentally. So student 2, what would you multiply together first to make it easier in the end?
6 times 2.
Really, you would? So you always like to make the multiplication harder. If I did 6 times 2, I'd have 12, right? And then I'd be having to do 12 times 12. I don't know. Totally it would work. It's fine. It's a community property, right? So I might have done 12 times 2 first. What's 12 times 2?
24.
And then 24 times 6 might be a little bit easier because you don't have to do a placeholder 0 and all that stuff, right?
Mm-hmm.
Either way, let's solve this. I think that there will be a lot of people out there who do 12 times 6 first. So I'm going to show that on the side to prove my thinking here. And I get 72. We should end up with the same answer. Let's see what you guys get. And then I'm going to do 72 times 2. So I'm going to have, did you guys get 142?
I got 144. But I did the same thing you did.
You're right, because 2 times 2 is?
4.
4. Very good. Very good. You found it. So 144, student 2, what's the label? What do I write, if that helps?
And there's supposed to be a 3.
Cubic feet.
Cubic feet.
Cubic feet. You've got it. All right, so we have Prism A. Now let's find Prism B. If you're a student at home watching, now would be a really good time to pause and see if you get all the same ones that we do, and then match up and see if you're on the right track. All right, let's keep going though. So for the length of Prism B, what do you guys think?
Go
ahead.
Would it be 6?
Yeah, length is always like laying down. So we have 6. All right, what do you think about width?
4 feet?
Yeah. Since it stops right here because of that cut we made, then we can use that 4 this time. Good. All right, and what about the height?
2.
All right. Yeah, I see it right there. It's on that side, nice and easy for us. So let's calculate the volume of this one. 6 by 4 by 2. What do you get?
48.
So you did 24 times 2, and 24 times 2 is 48. And we are still in cubic feet. So to find the volume of both of them, we have to put them together. Now, one thing to think about is, shouldn't our final answers be the same?
Yes.
But our individual prisms are not, because they're different sizes, different lengths, widths, and heights. So let's see if we do end up getting the same volume as we should with this type of cut that we made. So 144 and 48. Help me out. What do you get?
192.
92.
All right, 192. So we did it. We got them both. So it doesn't matter if you make a horizontal cut or more of that width type cut. You can find the volume of 2 different prisms and be able to put them together and find the volume of the whole thing.